Hey, seventh grade. So our learning target for today is really to talk about y equals mx plus b, and we're going to make it real. So we're going to talk about when in real life we would experience this y equals mx plus b situation. You should be on page 18. So in example 1, we're going to talk about that you spend $30 to enter Valley Fair. Now that's not a choice. Like, you have to pay the $30 to get in. That is going to become a very important piece of what we're doing today. That's going to become the beginning amount. We'll talk about that in a second. And then $5 per food item, which really is where the choice comes in. We're going to model that situation into a table. We have to hit the table, a graph, and we have an equation today. So all three pieces, we're going to talk about the same scenario. So if we think back to what we were talking about for slope. Slope is the movement, and y-intercept is the beginning amount. As I think about my Valley Fair scenario, and it cost me $30 at the beginning to get in. You have to pay that to get in. Now, food becomes a choice. You don't have to buy any food if you don't want to. But the thing that has to happen absolutely for sure at the beginning is you have to pay the $30 to get in. That's the beginning amount. That's known as the y-intercept. You have to pay that. Everything else becomes a choice, which is where the movement happens. So we have this movement that's happening between people, between scenarios, and there's a graph that would occur where we have $5 for every food item we buy. So if we buy 5 or we buy 1, it's $5. If we buy 2, we would grow $10. So our slope or our movement in this particular case really becomes that 5, because there's our rise, $5 for one food item. So there's our rise and there's our run. There's that fraction that's happening of a rise of 5 and a run of 1. There's that movement. The equation then, based on what we learned yesterday, is just y equals mx plus b. Y stays a stop sign, x stays a stop sign. But we do know now that the slope of this is going to be 5, x is a stop sign, and the y-intercept is 30. Now notice, we got all of that information just from the words. The equation is y equals 5x plus 30. So we're going to start with this equation piece over here, and we're going to ask, well, what would be true if we wanted to buy 5 food items? Now, some of you can mental math that, but instead, I would really like for you to use it algebraically into this equation of 5x plus 30. We know that it's $30 to get in. That's known as the beginning amount. We know it's $5 for each food item. So what if we put in, let's say we put in 5 food items here. How much is it going to cost? Well, for sure it's going to cost me the $30 to get in. And how much is it going to cost me for food? Well, 5 food items, $5 a piece, means that it's going to cost me $25 for food, and $30 to get in means that I better plan on bringing $55 to go with. So if I want 5 food items, it's $55. So for 5 food items, $55. What we did is we just proved it into an equation. Our work over on the left there is just the equation work of how much is going to cost me for 5 food items if I go to Valley Fair. $30 at the beginning amount, $5 per food item, and there we have it. So the next piece that we're going to work on is this table. And in the table, we're going to go ahead and say that all tables are in the form of x comma y. And really, the dollars is what we're kind of our dependent variable, our variable that's depending. We don't know how many dollars we bring until we find out, or until we know how much. We don't know how much money to bring until we find or figure out how much food we want to buy. So the x then is going to be our food. What if I don't want to buy any food at all? Well, if I don't want to buy any food at all and I just want to bring a big lunch, then I only need to bring that $30. So we always will start at 0, thinking about what would happen if I don't want to bring any food at all, or what happens right when I walk in the front door without anything else. Well, let's say when I want to buy 1 food item. 1 food item is $5, $30 to get in, $30 plus $5 is $35. What if I want to buy 2 food items? So 2 food items, they're $5 a piece, that's $10 for food, $30 to get in, I would need $40. And you might start to recognize a pattern here. We're going to go ahead and work that table to 5, because that's really what we were asked to solve. 3. What if I want to buy 3 food items? So 3 food items, they're $5 a piece, that's $15, plus $30 to get in, that's $45. How about 4 food items? Well, 4 food items, they're $5 a piece. That's $20 plus $30 to get in. I would need $50. And then the most important one, the one we're looking for here, is 5. What if I want to buy 5 food items? 5 food items, $5 a piece. That's $25 for food. Plus $30 to get in, I would need $55. So there's the same coordinate of 5 food items is $55. So we have a match so far. We have a match in our table. It matches what we said in our graph, that it would cost us $55 if we wanted to buy 5 food items. So this lesson today is about making it real into a table, a graph, an equation. So what I'm going to do now is I'm going to take that information and graph it. And I need to prove in my graph that it is going to be $55 for 5 food items. So we have the Valley Fair analogy here. Valley Fair analogy, here's my y-axis. My y-axis, the label's already available to me. I don't have to guess on it, I don't have to think about it. My y-axis, I should have labeled right from the table, is money. How much money should I bring? Well, I'm actually starting this at 30. So I don't really need to start the graph at 0. I can start the graph at 30. And then what I would want to do is I would want to run my slope from there. Now my slope we've set is $5 a food item. Always scale by your slope if you can. So we're going to scale by 5s because it's $5 for every food item. So we're going to use that slope value of 5. We're just going up here by 5s. So we go 30, 35, 40, 45, 50, 55. Now I really want you to pay attention of something that just happened on this y-axis. I just broke a major math rule. And this, when I am setting up a scale on a graph, I cannot jump from 0 to 30 and then scale by 5s. So if you notice right here, this is 0. I just jumped from 0 to 30. So I have a jump of 30, and then I go 5, 5, 5, 5, 5. That is a no deal. Like, that is a huge deal breaker in math. You cannot do that. You have to scale the same value the whole way. So we can get away with doing that if we break the graph right here. We put a solid break in that graph that allows us to jump from 0 to 30 with permission, and then I can go up by 5, 5, 5, 5, 5, which is our slope. Now I'm okay because I broke the graph down there in purple. The other axis down here is the x-axis. It's our food. It's the number of food items I'm going to purchase. And we talked about that I could purchase 0 and just bring my $30 and call it good, just bring a big lunch, or 1, 2, 3, 4, 5, because that's what we're working towards. If I were to graph these now, think of this as 0, 30, 0 up 30. So $0 food items is $30. Or if I bring 1 food item, it would cost me $35. 2 food items would cost me $40. 3 food items would cost me $45. You might see a pattern there. 4 over 4 food items up to $50. And 5 food items is $55. So we have this nice linear graph. And we're going to go ahead and prove that indeed that we have a match there, that 5 food items, right here, big bullet, 5 food items is $55. That's true. 5 food items, $55. So 5 for food, $55. We have proven in our table, our graph, and our equation that 5 food items is $55. Now, if this is too fast, you're confused, you're not sure where the slope came from, you should stop, rewind, go back. If you have a substitute today, if you need to slow down, go ahead and let the sub know. Otherwise, we are going to move on. In example 2, it says your cable company charges you $75 a month plus $2 per movie. So for our slope, our movement, and our y-intercept, our beginning amount, we're going to go ahead and think through this problem. Now, the beginning amount is what I like to start with because I think it's the easiest to figure out what is the fee that you have to pay. What do you have to pay at the beginning? You have to pay the $75. The cable company doesn't even care if you turn on your TV, but you have to pay the $75. So the beginning amount then would be $75. The choice comes in right here. This is a choice. Are you going to watch movies or not? Some families probably watch a lot of movies. Some families maybe watch more movies in the winter, but sometimes that changes from family to family. That is our slope then. It's $2 for one movie. There you can see that rise and that run kicking in there. So $75 at the beginning, and then the $2 per movie, that's your movement or your slope that kicks in after that. So my equation then is y equals, don't forget to write that y equals, the m is 2, x is a stop sign, plus $75. There's our equation, y equals 2x plus 75. Now using that equation, we want to know how much it costs for 6 movies. So I know you could mental math it, but I'm going to ask you to use it algebraically. So we're going to put a 6 in the x spot. So I'll put a 6 in for right here. How much does it cost for 6 movies? We are paying $2 a movie. 6 movies would be $12 for the movies, and $75 for your membership with the cable company gives you an $87. So it costs $87. So if you bought 6 movies, our coordinate would be 6 movies, $87. That's going to be very important in our work. We want to make sure we get a match in our table and our graph of the coordinates 6, 87. 6 movies, $87. So now our table, always in the order of X, Y, always in alphabetical order. Money as our dependent variable on the Y-axis. Number of movies here. And we need to work that to 6 because that's what the question's asking us about. So what if we don't want to watch any movies at all? Or what if we're not home? Do we still have to pay the $75? Yes. $75 is required. That's the beginning fee. And now we're going to work this table to 6. What if we wanted to watch one movie? Well, the movies cost $2. You have to pay your $75 fee, so you're going to need $77 at the end of that month. What if I want to watch 2 movies? Well, 2 movies are $2 a piece. That's $4. Plus the $75 is $79. What if I want to watch 3 movies? 3 movies are $2 a piece. That's $6. $6 plus the $89 gives us, or $79 gives us 81. What if I want to watch 4 movies? 4 movies are $2 a piece. That's $8. Add the $75 is 83. You probably notice a pattern here, which is great if you do. You can just go with the pattern. You don't have to go as slow as I am. 5 movies are $2 a piece. That's $10. $10 plus 75 is $85. And we're asked to work it to 6 in this particular problem. So 6 movies. 6 movies are $2 a piece. That's $12. Plus 75 is 87. So the good news is I did find a match. That 6 movies is $87. 6 movies, $87. So our job is to prove in real world situations that we have a table, graph, and equation matching. So what we have left then is our graph for our cable bill. So here's our y-axis, and here's our x-axis. The y-axis, the label on the y-axis is already calculated for us. It's right here. You don't have to think about it once it's in your table. It's the money. How much money do I need for that month? Well, the cheapest that I'm going to pay is $75, so I might as well just start the graph at 75. Now, we always want to use our slope if we can. So we're going to scale by 2, 77, 79, 81, 83, 85, 87. Scaling by 2. Now we talked about that we don't get to just jump up 75 and then go by 2s. We'd have to break our graph there. That gives us permission to go from 0 to 75 and then go by 2s. On that x-axis, we're talking about the number of movies. So the number of movies we would be increasing by 1, going all the way to 6. All right, so here we go. We're going to graph each of those. So we would say 0 movies cost us $75. Go ahead and put a data point at 0.75. Then we have 1 movie. 1 movie costs $77. We're going to go right 1 up 77. 1 movie, $77. 2 movies. 2 movies is $79. 3 movies. 3 movies is $81. 4 movies is $83. I see a pattern there. 5 movies is $85. And 6 movies is $87. We have this nice linear graph. We're going to just go ahead and prove that 6 movies is indeed $87. We're going to go ahead and drag it down. 6 movies, $87. We have 6, 87. 6 movies, $87. 6 movies, $87 is a match. So we have a 3 weigh match of table graph equation that it is 6 movies, $87. Okay, 7th grade, stick with me. I know this video is getting long, but we are going to compare our last example, and then you're going to go to homework. Last example on page 18, we're going to compare 2 different bank accounts. So we're going to talk about the bank accounts of Bridget versus the bank account of Amy. 2 different scenarios, so we'll end up with 2 lines, 2 slopes, 2 y-intercepts. So we're going to start with Bridget. Bridget has $200 in her savings account. She puts in $20 each month. So if we think about our slope and our y-intercept, our slope is our end, and our y-intercept is our beginning amount. It sounds to me like Bridget begins with $200. Her slope is $20 each month. That's the movement. So my beginning amount is 200, slope is $20 each month. Equation then is y equals 20x plus 200. Go ahead and take a look at that. Make sure you understand that the slope is the 20, the beginning amount is the 200. All right, so then we're going to go take a look at Amy next. So if we look at Amy, it looks like Amy starts with $0 in her savings account. Amy has 0. She puts in $60 each month. Amy's beginning amount this time is 0. She doesn't have anything to start with, but she's putting in more money per month, $60 in each month. Her y-intercept then is y equals, or her equation then is y equals 60x plus 0. Now we really only would need this y equals 60x. Y equals 60x. Okay, having said that now, so let's go ahead and talk about when, the question down here is asking us, when will the 2 girls have the same amount of money? So we don't really know based on just these equation work. We will talk later in 8th grade math of when we'd set those 2 equations equal to each other and we could find that value. But at this time, we don't really know. So what we're going to need to do is work through this table. I don't know how far to work the table out. I'm looking for a match. When do the girls have the same amount of money? So we're going to set up the table of x, y, as we always do. And our dependent variable, the money, the thing that's depending, the amount of money depends on how many months has gone by. So the amount of money compared to the number of months, Amy's same scenario, and that amount of money compared to the number of months. Now these girls are in a little different scenario. Bridget starts with money in her bank account. She's only putting in $20 a month. Amy doesn't start with anything, but she's growing pretty fast at $60 each month. So Bridget doesn't start with any, or pardon me, at month 0, Bridget starts with 200. Now again, I don't know how far to work this table because we don't know when the 2 girls will have the same amount of money. That's what we're looking for. 1 month goes by, she puts $20 in. Bridget now has $220 in her bank account. 200 plus she's adding the slope of 20. Month 2, another $20 goes in her bank account. Now she has $240. Month 3, another $20 goes in. Now she has $260. Month 4, another $20 goes in. Now she has $280. And because I'm running out of room here, I'm going to stop at month 5 and just see if we can come up with a match. At month 5, Bridget has $300 in. She's just increasing each month by $20. So she starts at 200. Her y-intercept, she's increasing by her slope of $20 each month. I ran out of room, so I kind of stopped there, but I'm hoping that I can get a match somewhere within that range for Amy. Amy at month 0. So she goes to the bank, she opens up a bank account. She actually puts $0 in, but she still wants an account open in her name. 1 month goes by, she's putting $60 in, so that's 60. So she's growing quicker, but she just doesn't have anything to start with. Another month goes by, she adds 60 more dollars, she now has $120, 60 plus 60. At month 3, she puts another 60 in, now she has 180. At month 4, she puts another 60 in, she now has 240. Looking to see, do we have a match yet? We have 240, but Bridget's at month 2 and Amy's at month 4, so no. Same amount of money at the same amount of time as we're looking for. At month 5, she puts in another $60, which is $300. Ooh, there it is. At month 5, both girls at month 5 have $300. So we can go down here and say, when will the girls have the same amount of money? At month 5. At month 5, both girls have $300. At month 5, both girls have $300. We're going to go ahead and prove that in this this graph as well. A little bit tricky to do this graph though because you have two lines on the same graph. So we're going to call it the bank account. The bank account. So we have this y-axis here. We have this x-axis here. Y-axis there, x-axis there. And we don't have to guess on the label of the y-axis. It's available to us. The y-axis has a label of money because it says it right there. Now in this particular case, we're going to have to decide on our slope or which slope we want to use because I said try to use the slope if you can. Well, my slopes are either 20 or 60. So the problem I have in this particular case is we have two different slopes for these problems. I would recommend then whenever you have two different slopes, use the bigger of the two slopes. Bigger of the two slopes just to get you going. So we're going to use 60 as our slope. We're going to start at 0 and we're going to go by 60s. Now Bridget's graph will be a little trickier to graph because, so I'm just increasing by 60, I'm increasing by Amy's slope. Bridget's slopes, our graph is going to have a little bit more of a guessing game to it because we're not using her slope, we're using the bigger of the two slopes. Now I don't have to put a jump in the graph this time because I'm going by 60s the whole way. I'm going by 60, 60, 60, 60, 60, so I do not have to jump the graph this time. The number of months would be my x value. So I'm going to go 1, 2, 3, 4, 5 is looks like where we got our match. We have our match, so we're going to go up to month 5. All right, so I'm going to start by graphing Bridget, which is going to be a little bit trickier because there's going to be some guessing involved with graphing her. The first one is 0 to 100. So Bridget starts with $200 in her bank. 0 to 100 is a total guessing game, but it's about right there. Then at month 1, she puts $20 in, so I'm going to go right 1, and I'm going to go up to about 220 again, which is just a guessing game. Not easy to graph when you have to guess where the data points are. Amy will be much easier because we used her slope. Right 2 up to 40, that one sits in a nice place. Continue to graph her. Right 3 up to 60, right 3 up to 60. Right 4 up to 80, so we're going to go right 4 up to 80. And right 5 up 300. So this would be the graph then of Bridget. So you can see that she starts at $200. She's growing by $20 a month as her slope. That's the graph of Bridget. We're now going to graph Amy. Amy actually starts at 0. She starts right down here at the origin. But this one's going to be a little bit easier to graph because of the slope. After 1 month though, she has $60. Nice intersection there because we're using her slope. Right 2 up 120. Right 3 up 180. You might see a pattern there. Right 4 up 240. And right 5 up 300. So this is the graph of Amy. And you can see that those two girls intersect. So you can see that Amy's going to eventually take over and start growing at having more money in her bank account after month 5. So we have this intersection that happens right here at month 5, 300. So month 5 is $300. So we go ahead and confirm that those two girls have the same amount of money at month 5, $300. All right, 7th grade. So this is a make it real lesson. Y equals mx plus b. When would it happen in real life? We talked about Valley Fair, the cable company, a bank account, all of these scenarios. Your job is to do 3 very similar problems on page 19 for homework tonight. Have a fabulous night.